Hello everyone and welcome to today's presentation sponsored by Seal Aftermarket Products. Just a note to let you know that if you've missed any of the past webinars, a few days after they've finished on the web, we actually place a recording of them on our website at ATRA. You can go to the website, download the video, and have a copy for yourself. Also, if you're a non-member of ATRA and you can't go to our website, just go to Seal Aftermarket Products website since they sponsored them. They will be available there for you also. With that said, let me show you a short video from Seal Aftermarket.
Seal Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At Seal Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and Acura transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments or questions about past webinars or anything like that, send your emails to webinars@atra.com. If you have any questions during the webinar, feel free to go ahead and text them to me, and I will try to answer them the best that I can. This is the webinar schedule for the rest of the year. There have been a couple of changes. As of September 29th, we'll be doing the 6R60 and the ZF6HP comparison. That was a change made. Next webinar will be July 7th and 8th on the DPS6, the dual clutch Ford direct shift gearbox. Bill Brayton will be presenting that one. This year's expo will be again in Las Vegas at the Rio, just like last year. It will be October 29th to November 1st. Which is also a great time to be in Vegas during Halloween weekend. This is the schedule for the seminars throughout the states for the rest of the year. The next one will be August 8th in Albuquerque, New Mexico. As well as the door prizes that are given away during the seminars around the country from the vendors, ATRA has also given away a few door prizes ourselves. This year we're giving away a one management package to the expo. So you'll be able to go to all the management seminars for free. It does not cover the cost of travel expenses or anything like that. We also give away 1 month free tech at ATRA. If you're already a member, 1 month's fees will be taken off your bill. And we're giving away also last year's expo book with almost 800 pages of tech from all the different seminars we did there. And then last but not least, we're giving away a full boat to the expo. That's the tech seminars and management seminars all in one for free. And we're also going to cover 4 nights at the Rio, so you get to stay at the Rio for free also. You will have to just cover your expenses while you're there, and obviously your travel expenses. Today's presentation, we're going to talk about the Torque Shift 6, or the 6R140W from Ford. Obviously, this is a 6-speed electronically controlled trans. It has a converter with a integral converter clutch. The electronics control the shift as well as the pressure controls. It has one single planetary gear set and has a double Ravenor planetary gear set also. There's going to be 2 holding clutch sets and 3 driving clutch sets. And there is also a one-way holding clutch or sprag in this unit also. Now, the valve body assembly with the solenoids inside the trans are controlled either by a PCM for gas engines or a trans control module, or TCM, for diesel engines, both located outside the transmission. So we won't find any computers on the valve body with this unit. In the event of a system fault, the computer will provide what's called FMEM, Failure Mode Effects Management. Basically, it will set the transmission to maximum pressure. It'll function as normal unless there's a problem with one particular gear, then it will actually omit that gear. If there's a complete loss of electrical power to the transmission, you'll still be able to use park, reverse, neutral, and drive, and also 5th gear is retained hydraulically. Here are the component locations on the transmission. As you can see at the bottom left, we do have access to put a PTO, a power takeoff unit, on the side of the trans. You can see the forward clutch up front. That's on for 1st, 2nd, 3rd, and 4th. The direct clutch, which covers 3rd, 5th, and the reverse. And then we have the overdrive driving clutch for 4th, 5th, and 6th. Now, the intermediate clutch is on in 2nd and 6th. That's a holding clutch, a brake clutch. Then you also have the sprag, and then all the way in the back we have the low reverse clutch, which is also a braking clutch. And you can see the single planet is up towards the front, and we have the double planet towards the back. Here's the clutch apply chart. We have some gear ratios there for you on the right. We also have the stall speed for the converter, whether it's diesel or gas. What I want you to look at here is 1st gear drive. As you can see, the forward clutch is on. That's a driving clutch. Then we have the low reverse clutch, which is a holding clutch. Now, the one that's in parentheses, if you look down below, you'll see that the low reverse clutch is holding till the vehicle actually reaches 5 miles per hour approximately. At that point, they will turn that clutch off. Now, if the sprag is not holding, you could have an issue with a flare going into 2nd. It could actually neutral out before going to 2nd. This is a problem we've ran into in the past with the Dodge with the 545 RFEs. The 68 RFEs work the same way. We've had several different transmissions that were misdiagnosed, thinking they had a pressure problem because of this severe neutraling or flaring going into 2nd. The whole time was just being the fact that the low overrun clutch was not holding. We have some shift speed charts for you here. This one's for gas engines. I think this is good information. A lot of times we get calls on the tech line, guys wanting to know what the shift timing should be, when lockup should come on and come off or not come on. And as you can see by the 1 and the 2 and the 3 in parentheses, we're showing you at the bottom that on gas vehicles, the TCC will lock in 3rd gear between 2nd and 3rd, and also between 3rd and 4th. Now, the accelerator pedal has to be above 30%. So obviously, if we have a very light throttle, you will not get a lockup command. Now, the second one down in tow haul mode, you'll see that the 3rd gear locks in 3rd gear. Also, the 2, 3, and the 3, 4 between those shifts. Again, that doesn't matter now on the throttle opening, because with tow haul mode on, the lockup should still apply. And then you can see the number 3 at the bottom, lockup will come on in 5th gear, also between 4th and 5th and 5th and 6th. Again, the accelerator pedal has to be below 30%. So this is considered normal operation. Here's the shift speed charts for the diesel engines, and you have some lockup information there also. Now, solenoid body strategy. This is not uncommon for a lot of the newer vehicles that the solenoids will have separate part numbers. These are for different strategies on the flow rate of the solenoids and the software that controls them. Now, what you're going to find is there is a solenoid body strategy file programmed into the PCM or TCM, whether you have diesel or gas. Now, the solenoid body tag in the transmission case contains the 13-digit solenoid body strategy and then the 8-digit solenoid body identification. So this would be a good time to use your phone camera or a small camera that you keep by the bench. Take a picture of this tag before it hits the parts washer, because this is vital information that we don't want to lose. So this would be a great time to record that and keep that information. So anytime a new valve body is installed or a new solenoid body strategy file is downloaded into the PCM or TCM, you're going to need a capable scan tool. Replacement solenoid body tag is supplied when you buy the new solenoid body. This contains the 13-digit solenoid body strategy and the 8-digit solenoid body identification. As you can see here, the new tag would be placed over the original one with a solenoid body tag. You just place that over that one there. Again, if we're not changing anything, we do want to take a picture of this tag also and keep that on file. Now, if the solenoid body strategy printed on the tag or the solenoid does not match the solenoid body tag on the side of the case, a new valve body must be installed and the solenoid body strategy must be downloaded into the PCM or TCM. Now, you could have problems of harsh shifts, erratic shifts, harsh engagements. This could be due to the fact that the solenoid body strategy is not programmed into that PCM. This happens quite a bit when guys will swap out valve bodies with used ones or reman ones, and they don't update the software for it. This is going to be something that's coming over the tech line quite often. Now, when you're using your scan tool, you're obviously going to select the module programming, and the programming parameters will then select the transmission. Then we follow the instructions displayed on the scan tool. Now, there are going to be fields there to enter the solenoid body 8-digit and 13-digit strategy. Now, this is recorded off the tag on the main control. Now, if the solenoid body information is not correct, transmission damage or drivability concerns will occur. So you need to enter the solenoid body identification and strategy. Now, the scan tool will verify these numbers entered if they're valid and display a message if the information is not valid. The scan tool checks to see if the file is present on the scan tool. If the file is present, obviously the technician can proceed with the download. If the file is not present, you're going to have to connect the scan tool to what's called PTS, Professional Technician Society. It's a server to download the file onto the scan tool, and that can be found at the Ford website. Now, once you verify the file is present on the scan tool, if the file is present, just go ahead and go to step 8. If it's not, we'll continue with this procedure. Now, we'll connect the scan tool to the PTS server. The screen will display a progress bar when connecting to the network. Follow the instructions on the network to download the strategy file onto your scan tool. If the scan tool cannot connect to the server, the PTS server, download the file from the Ford website. And if the scan tool cannot download the strategy from the website, a partial strategy is downloaded automatically. Now we'll have to reconnect the scan tool to the vehicle, follow the instructions displayed on the scan tool, If a new main control valve body was installed, clean the existing solenoid strategy tag off the case and cover it with the replacement solenoid body tag. Now, the scan tool automatically downloads the file or the partial strategy file to the PCM or TCM. Now, the scan tool should display a message when it's finished downloading. When it's finished downloading the data, stating that the file was downloaded successfully. Now, once this happens, the adaptive drive cycle has not been performed, the customer still may feel erratic shifts and drivability concerns. You still have to perform the adaptive drive cycle. Now, we can refer to the shift point road test in the other section to see if these shift commands are correct. So we're still going to have to do some type of a drive relearn even after all the software and everything's been updated. Now, like I said before, these solenoids are calibrated from the factory and they're not all the same. They do all have the same color connector, but there are two types of solenoids, normally high and normally low. Now, these solenoids can be replaced separately, but only by the same type of solenoid. The band number that you see here on the solenoid must match the band number of the solenoid being replaced. These band numbers identify the difference in the flow rates and the strategy of the solenoid. Now, these band numbers are stamped as you see here on the right. They're stamped right into the metal. Now, there is a TSB from Ford. This is not in your handout. You may want to take a snapshot view of this slide. In your upper right-hand corner of your screen, you should see a camera icon. Just click on that, and it'll take a snapshot picture of this slide to save it right on your desktop. The TSB number is 11-7-10. This is concerning a 2-3 flare. Now, part of the TSB will tell you that you may have to change several of the solenoids. Depending on the build date, it may require replacing the solenoid and a computer update or just a computer update. So depending on the build date, you may only have to do a reflash. Again, you may have to do the reflash along with several of the solenoids. These are how the solenoids function. Normally high, as you see in the upper left. Low current. You can see that the solenoid feed circuit supplies oil to the solenoid between the two O-rings, and the valve will block off the exhaust and all the pressure will go to the output. Once we start to run some current through these, you'll see the valve open up, allowing some of the solenoid feed circuit to bleed off into the exhaust. And this will create a lower pressure to the output. All the solenoids measure the same resistance, 4.8 to 5.4 ohms. And you also have a list below that identifies each solenoid and what clutch it controls. And also the solenoid type over to the far right. Now, we recommend marking the casting on the valve body and marking the solenoids so that when they are removed, that they will be placed back into the same location that they came from. And now we're identifying all the solenoids here for you as far as which ones are for each clutch, also whether they're normally opened or normally closed. As you can see by this chart here, we're showing the part numbers for the normally high and the normally low solenoids. Now, you'll notice on the left we could have the same band number, but the part number is different, so we don't want to mix these solenoids up. So somebody said to me, what's the easiest way to determine the normally high from the normally low solenoids? Obviously, when they're in the valve body, as you see here, we cannot see the snouts on the solenoid. But you do see the outer edge, as we're pointing to here with the arrows. And you can see that some of these solenoids have a brown snout and some of them have a black snout. Now, the black one is normally high, the brown one is normally low. Again, if I'm going to swap one black one with another one, I have to make sure that the band number is the same. Not the numbers that you see that we scribed onto these were just to identify their location. You have to look for the band number that we showed you in the earlier slide. Then you'll be able to exchange the solenoids. Here's your solenoid apply chart. Want to point out again in drive, first gear. Over towards the right, you'll see that the SSD solenoid for first and reverse is off. And then as you're going about 5 miles an hour, you can see that little number 1 in the parentheses. The solenoid will change state, and that's at that point when it drops the low reverse clutch. At this point, the sprag has to hold, or we're going to have a definite neutraling or flaring going into the next shift. And on the far right, as you can see with the number 2 in parentheses, you could actually have the TCC command the converter clutch on early in first gear, second gear, and third gear. It depends on fluid temperature. We've also given you in your handout the case connector pin ID, and the resistance for each solenoid is listed there also, so we can check all the solenoids and the speed sensors, range sensor, all that can be checked right here at the case connector. We also put the pin IDs for the range sensor, and you can see it's fed 12 volts, it has a ground, and then we see a PWM signal. Now this is something we first seen in the 6R140Ws. The signal coming back to the computer, as you see just below the connector, is a duty cycle. And you can actually put your meter on duty cycle, or if you want to use a scope, you can monitor that signal. So you have the pin ID to do that. And this was a good way to check the range sensor to see if it's working correctly. There's 2 speed sensors, one turbine, one output speed. They're both Hall effect. Now these sensors, although they are fed 12 volts, as you see there on the right, the signal will actually be a 5-volt DC square wave back to the computer. So you'll have only a 5-volt square wave, although they are fed 12 volts. This is the information for the transmission fluid temp sensor. As you can see here, it just clips right there into the valve body casting. And it's a regular thermistor type. The less resistance, the higher the temperature will read. And we've given you that temperature in Fahrenheit, Celsius, and we've also given you the resistance, so you can check the sensor all 3 ways. Now during overhaul, to remove the valve body, all you need to do is remove the bolts that we show in the circles on the left. The one most often forgotten is the one single one right there by the solenoid connector for the tube. Now once the valve body is off, the bolts that we're showing you on the right, there's 2 different lengths. The bolts marked B are 63 millimeters, the A's are 47. These are the bolts that will have to be removed to split the valve body. And now you have the locations for where the 4 longer bolts go. Once we take the valve body apart, we're going to find some small parts and check balls, and you can see that we're showing you that here. There are 3 check balls located here and 2 check valves. Really important, do not mislocate or lose this pump inlet nozzle. This has to go back in the valve body. So it will cause problems with the pump pickup. This is the upper valve body valve identification. We also give you the spring dimensions. We identify each valve and what clutch it regulates. And we also have the spring dimensions there. So if you lose one of these springs, you have the dimensions, you can pick up another one or match it to something that you have. Now in the lower valve body, same thing. We identify each valve for you along with the spring dimensions, and we have 1 accumulator that goes here. We have to make sure that we check this accumulator. The rubber ball at the bottom is not flattened. The top edge of the accumulator, just like when we work on the ZFs, it has to protrude up above the casting of the valve body. Now the center rings on the input shaft are solid rings. There's 4 of them on the shaft and then 1 on the tip of the shaft for the converter clutch. Again, some guys like to reuse the rings. That's totally up to you. If that works for you, that's fine. But you do need to change these. They should be changed if they're worn out. Also, on the other side of the drum, we want you to look at that bushing. That I feel it's something that should be changed on every rebuild. But we want to make sure that this bushing is not worn out. Don't forget, this is a heavy-duty vehicle. It's going to be used for a lot of work use. So we want to make sure that that bushing is definitely good as well as the others. And check that bushing surface where the other drum goes into it. Make sure that that bushing surface is also good. Now when it comes to putting new ceiling rings on this, there's 2 tools that you're going to need. You have the tool numbers there for you. And we give you the directions, obviously, to clean the tool, put some lubricant on it, and then we can slide the rings down onto the shaft and then resize them with the other tool. I've had other guys do alternate methods of doing this. They'll put the ring in there, wrap some electrical tape around it, and use a hose clamp. That's fine if it works for you. If not, you want to pick up these 2 tools for this. Now the output shaft nut is very similar to what we've dealt with on the 6R140W. This particular nut is very tough to get off. They use some super strong Loctite at the factory. And I want to tell you something, you really need to heat this up before you try to take it off. I've seen guys go through several tools, keep stripping the tabs off the end, trying to do this without heating it up first. And there's the tool number that you'll need. The shaft nut socket is available from Ford. You have the number there. Now it's not cheap. It's about 250 to 300 bucks US. I'm sure down in Australia and Canada it'll be much more. You can search the internet or check with the aftermarket to find them for much less. It's basically the same tool as the 5R110. The nut is just bigger. Now this is a pretty hefty unit. It weighs about 350 pounds or 160 kilos. And that's with the torque converter installed. It's slightly heavier than an LCT 1000, about 20 pounds or 10 kilos difference. Now you can muscle this thing around on the bench if you like, getting it up and down from the bench. It's pretty heavy. I know that my back hurts just thinking about lifting this up onto the bench. You can take a few minutes and put some tools together, or you can even make some tools to make the job much easier. As you can see here on the right, that's the input drum assembly that has to be installed in one piece. That weighs 75 pounds by itself. Now here's one of the tools that Ford has available to install the input drum. And you have the tool number. I don't have the price of that tool. You can also use an old Allison case as a stand if you want to stand it up on the case rather than put it on the bench. Keeps it much lower and easier to work with. Now this is a duplicate tool that was made pretty quick and pretty easy to do. Just take some square tubing, put an eye bolt onto it, a couple of pieces of flat steel. Just duplicate what you see here, and then you can bolt the 2 steel plates together and make your own tool to go ahead and install that drum, that whole drum assembly. Just a quick parts comparison of just the planets. This is the low reverse planets on the 5R110 on the right and the 6R140 on the left. There's a tremendous difference in size of these parts. It's a pretty hefty unit. This is the Ford patented rocker one-way clutch, or diode. I'm not a big fan of diodes, but it seems like more and more transmissions are going this way. Now this diode is actually integrated into the carrier. Now this is to help improve the 1-2 shift quality throughout the gear set. Remember, like I said before, we're going to release the low reverse clutch on takeoff, So this is the diode that's going to hold before it makes that shift in a second. So now we don't have to worry about releasing one clutch to bring on another, which could affect shift quality either by flares or bind-ups. By just having this sprag in there, we can release the clutch long before the second clutch comes on. Then when that clutch applies, the sprag will just rotate and freewheel the other way. Now this is the torque converter. As you can see here on the right, this thing by itself weighs about 66 pounds. It has an internal spline for a PTO. It also has a splined hub for the pump itself. So whenever the engine is running, the PTO gear inside will be turning. They wanted to do this so they wouldn't have to use the any clutch or torque converter clutch to engage the PTO. If you had a PTO gear on this, you would see the drawing that we have for you on the right, and the gear would actually protrude right out there in between that space that you see the arrow pointing. Another thing I noticed about this transmission, I just want to make a note of, the front sun gear is actually splined to the stator support, so it's held all the time, very similar to what we've seen in ZFs with the La Peltier gear train. Two case seals I want to point out here. There's one right there in the center of the case. Remember earlier I was talking about that one single bolt that has to be removed. Well, underneath that tube right there, there is a seal that goes to the case. I want to make sure that gets replaced. Also in the back of the case where the tubes mount up, there's 3 more tubes there that are color coded. There's one dark blue, a black, and a green one. Also up front of the case, where the valve body will seal down to the case itself, and you can see the pump inlet and outlet right there. The sleeves need to be checked, and these seals need to be replaced during every rebuild. Once it's all assembled, we can go through the underneath the case here with the valve body off, and we can air check all our clutches, including the torque converter. So we have all the air checks identified there for you. There's a line pressure tap on the left side of the transmission up towards the front. It's an Allen head type, and the threads are 10 millimeter by 1.0 millimeter. So it's right there between the bell housing and the linkage. Now the line pressure charts that you see here, there's a pressure chart for diesel engines. Also there's one for gas engines. We give that to you in kilopascals as well as PSI. And you can monitor this with a gauge while seeing what the command pressure is on your diagnostic scan tool data. This transmission takes Mercon LV. I would suggest using it. There's a local shop here that does quite a few of these. They were using a multi-use good name brand synthetic. Seemed to be working fine, and one day they had one that gave them a TCC chatter that they just couldn't get rid of. Since they had used the other oil consistently without problems, they assumed they had a problem with the trans. They took the trans back out, found nothing wrong with it, had the converter recut, rechecked, still couldn't find anything. Once everything went back in the vehicle, it still had a converter chatter. They went to use the Mercon LV, and that took care of the problem. Now, fluid level check, there's 2 different types of dipsticks. The measurements are pretty much the same. You have the fluid capacities for gas and diesel there. So there's an early and a late dipstick, and that's what they look like. We also given you the clutch quantities for each plate. The diesel obviously takes more than the gas. As you can see in the first one, the forward clutch, it takes 5 frictions and 5 steels. And then the gas engines will only take 3 clutches and 3 steels. Obviously, if we wanted to make a gas engine more durable, we could use the same frictions from a diesel to beef up those clutch packs. We also gave you the clutch clearances here in these charts. You have them in millimeters and inches. And obviously there is a difference between the diesel and gas engines, except for the low reverse clutch. The low reverse clutch that we're showing you here at the bottom is the same for both. You'll also notice too that the specification is measured of the height of the low reverse clutch, not the actual clearance. And you have the chart with the part numbers for all the selective snap rings that you'll be needing for the forward intermediate clutch, forward direct and intermediate at the top, and then we have the overdrive clutch snap ring chart there for you at the bottom. When it comes to checking unit end plays, if you have to make any adjustments, you can see here that you have the part numbers for the shims, selective shims for the front, as well as the selective shims for the rear of the transmission. And you also have the total end plate clearance right there at the bottom of each chart. And then we have the specifications for all the torque specs. This includes everything on the transmission from the manual shaft all the way through to the valve body. We have it in Newton meters. We have the foot-pound and inch-pound displayed through there also. Data pin identification. A lot of times when I'm working on a new vehicle I haven't dealt with before, sometimes I'll be scrolling through the different data pins, and sometimes I'll read something that just doesn't make any sense. So it's nice to have a chart like this that actually explains what the data pin means, the description of it, and also the units that you'll be reading from it. We have several more here. These are for the actual shift solenoids. So you'll be able to read the current that's being sent to the solenoid, as well as what the pressure should be reading. So we can actually check that with the scan tool and a pressure gauge. Here you have all the torque converter data pins, and the temperature sensor, and the range sensor at the bottom. And these last few on this last slide here, this is just showing you vehicle power and VSS. So you have all the data pins for that vehicle if you're working on one of them. So you'll definitely need a capable scan tool that'll give you this good information. And that about does it for today's presentation, sponsored by Seal Aftermarket. We'd like to thank them for making this presentation free to everyone, as well as non-members. So if you have any questions, please go ahead and